So the T distribution involves something called degrees of freedom, which is the number of values in a collection of sample that may vary after certain restrictions have been imposed. Right. So I came up with this little example here where it says, assume you have a sample set with 5 values whose mean is 45. How many values do you have control over? That is, and for whatever reason, I decided I wanted to write like textbook like here. You can select any numbers you wish to be part of the set, but at some point you lose control. This is like a 20-year typo. Lose control over which numbers must be included. When does that occur? All right. And actually, I'm not even 100% sure a semicolon is appropriate there. I'm pretty sure it's supposed to be period new sentence, but whatever, I'll take it as a typo also. Yeah, this is what I call a legacy typo. This is one that I guarantee I pointed out before in previous semesters, just nobody ever submits it for bonus. And so there it stays, you know. Anyway, let's say, for example, you know, in this case, we have a mean of 45. And a sample size of 5. All right. The mean formula, the definition of a sample mean is the sum of the x values divided by whatever the n value is. Okay, in its most simple. All right. So we know that the mean is 45 and the n is 5. So that would give me 45 is equal to the square root, the sum of x over 5. If I wanted to solve for the sum of x, just quick cross multiplication. As you know, I like to keep the algebra light in this course. This is kind of the extent between this and linear regression way back in the first unit. That's really all there's been. When you cross multiply, 1 times the sum of x becomes 1 times the sum of x, which is the sum of x. 45 times 5 is 225. All right. What that tells me is the 5 numbers need to add up to 225. All right. So what I can do is come up with 5 numbers. All right. So let's say I have the first number. All right. First number. And I want that number, and I'm choosing this arbitrarily off the top of my head. I want that first number to be 5, I guess. All right. Along the side of that, I would be saying, okay, well, I have 225 to work with, a total of 225. I've already just used 5 of that 225, which means I have 220 left over for the remaining values. All right. So that would be 1 value accounted for. So let's say I choose, and these are, I'm making these choices. I'm choosing them. There's no rhyme or reason, except I felt like choosing the number 5. I had control, so I can choose whatever I want. All right. So I'm going to choose another number. My second number, let's make that, I'll make it 100. Let's kind of get the show on the road here. All right. So let me get a nice light blue there. So that means out of the 220, I'm using up 100, which means I have 120 left over. All right. So now I've chosen 2 values out of the 5 that I need to work with, right, in order to have an average of 45. Right. So maybe I can choose another one. Maybe the next one. Let's see, 120. I'll try to make it nice and round. Let me go with a 20. So I'm using another 20 out of the 225, or in this case, 120, leaving me with 100. Let me get a fresh new color here. Let's go to I've already used an orange. Let's go this like purplish, pinkish kind of color. All right, so I'm going to choose a fourth value. The fourth number, let me say, let's say that fourth number is 50. All right, so that fourth number is 50. Now I'm limited. I don't have a choice anymore. Let's go with, I'll just do a gray. Boring, drab gray. I don't have a choice anymore because I only have 5 values to work with. And they have to add up to 225, which means that whatever this number is, that has to be my last entry. I don't have a choice. I lost control over my data set, right? These are all values I have control over. That last one, I don't have control. It's based off of the other 4 that were selected, right? So what happens here is my degrees of freedom would be the number of values that I have control over, would have to be 1 less than the total number of values in the data set, right? So if I have n, I would subtract 1 from it. In this case, it would be 5 minus 1, which is a result of 4. Right? So that number, degrees of freedom, very, very simple to compute. You just take the number of values in the data set and subtract 1 from it, or in the sample specifically. You take 1 away from the number of values in each sample, and that's your degrees of freedom. But that's the driving force behind that student t-distribution, right? So if you look at the t-test calculator that I created, you see that it calls for significance level. So every hypothesis test has a significance level, so that's nothing new. Sample size, but then because just the way Desmos is programmed, it doesn't let you let a variable be 2 letters unless you start using subscripts, which looks kind of funky. So I let D be the degrees of freedom, even though the notation calls for DF, but it's fine, right? And so you can see here, I just plugged it in. D is equal to n minus 1. Degrees of freedom is equal to n minus 1. So with the n value of 30, the degrees of freedom would be 29. If my n value is 15, you can see that the degrees of freedom is 14, right? So it automatically accounts for that. All right, but this gives you a little bit of a theory, or a little bit of a sense of the theory behind the construction of a data set. Because if you know that the sample mean is supposed to be some particular value, then there's a wide variety of ways in which you can develop a sample, almost infinitely many. If you get negatives and decimals involved, especially irrational numbers and things like that. But the second you hit that 4th value in a 5-unit data set, you lose control over it. So you can no longer assign numerical values to certain positions within the data set after you've reached that threshold being n minus 1. Okay. So little compare and contrast here. The shape of a z distribution compared to a t distribution, they're both bell-shaped. The difference between one and the other is that the t distribution changes in shape and size based off of the n value. All right, so for a smaller value of n, and therefore degrees of freedom being smaller, you're looking at a short and wider graph. If when the n value gets larger and larger, it gets taller, it gets skinnier. It in fact approaches in shape a z distribution. All right, so in fact, I can even show you really quickly. Here's a normal distribution. I'll just pop it in here. with parameter 0, 1. This is the normal distribution. I'll just turn it off real quick, just so you can see that it's overlapping on top of the t distribution. The blue is the t, the red is the normal, all right? But you can see I'm looking at a relatively large sample size of 30. But let's say I have a small sample size of, let's say, 2. I'll change my window a little bit so it's a little easier to see. I'll make it go to 0 to 1. The blue is the t distribution. You see, for a small sample size, it's shorter, it's wider. As I increase the sample size, it gets closer and closer to being the same thing as the z distribution, until once it reaches a certain size, it actually becomes the z distribution. Right? So that's the beauty of this thing. It's very malleable for small sample sizes, but then once you get to a certain threshold, you'd say, okay, I don't need the t distribution anymore. I can use the z distribution. All right. The center is always going to be t equals 0, just like for the z distribution, it was z equals 0. And the variation, instead of being sigma related, it's going to be S related, the sample standard deviation, as opposed to a population standard deviation. All right. So I'm going to get rid of this because I don't want it to be a distraction. But that's a general overview of the t distribution. There's a lot more that goes into it, and I hate to do this. The justification for a lot of this is rooted in pretty advanced calculus. So there really isn't much more to talk about in terms of where these rules and formulas come from, because you'd have to get into a higher level of calculus in order to understand it. It's unfortunate, but that's the way of it. All right, so let me stop that recording.